Imagine the entire AI world as a giant classroom full of very smart robots. ChatGPT is writing essays, Google is answering questions, Tesla is teaching cars how to see, hospitals are scanning medical images, and every company is screaming the same thing. We need more brain power. Now here comes NVIDIA, not as the robot, not as the app, not as the website, but as the company selling the brain factories. In 2025, NVIDIA reported fiscal year revenue of $130.5 billion, up 140% from the year before, and its data center business alone reached $115 billion. That is the simplest way to understand NVIDIA. It became rich by selling the shovels during the AI gold rush. But NVIDIA did not begin as the king of artificial intelligence. It began as a company trying to make video games look less terrible. Jensen Huang, Chris Malachowski, and Curtis Priam founded NVIDIA in 1993, and the famous origin story starts inside a Denny's restaurant, where three engineers talked over food and coffee about a future where computers would need special chips for realistic 3D graphics. At the time, this did not sound like the foundation of a trillion-dollar empire. It sounded like a nerdy gamble on gaming. But the key idea was already there. Normal computer chips were good at doing one difficult task at a time, while graphics chips could do many tiny tasks at once. Explain it like you are 5. A CPU is like one very smart teacher solving math problems one by one on a board. A GPU is like a stadium full of kids, each solving one tiny piece of the same problem at the same time. If the job is to write one poem, maybe the smart teacher wins. But if the job is to color millions of pixels, simulate weather, train a neural network, or multiply huge grids of numbers, the stadium wins. NVIDIA's genius was not just making faster graphics. NVIDIA accidentally built the perfect machine for the kind of math that would later power modern AI. The first years were not glorious. NVIDIA's early chip, the NV1, was built around a technology path that quickly lost to the direction Microsoft's DirectX helped push the gaming industry. The company had to pivot hard. Then came the Riva 한루시페일 in 1997, a triangle-based graphics chip that finally matched where the market was going. NVIDIA's own timeline and contemporary GameSpot coverage say the Riva 한루시페일 sold more than 1 million units in its first 4 months. That was the moment NVIDIA stopped being just another struggling startup and became a real graphics company with oxygen in its lungs. Then came 1999, the year NVIDIA launched the GeForce 256 and popularized the term GPU, Graphics Processing Unit. NVIDIA described it as a single-chip processor with integrated transform, lighting, triangle setup, clipping, and rendering engines, powerful enough to process at least 10 million polygons per second. Wired covered the unveiling at the Intel Developer Forum that year, when the chip was still about games, graphics, and making digital worlds feel alive. Nobody at that moment was saying, one day this will help build large language models. But the foundation was being poured. For gamers, NVIDIA meant smoother movement, sharper worlds, better lighting, and monsters that no longer looked like card-wearing wet paint. For game developers, it meant they could build bigger worlds without asking the CPU to carry everything. For NVIDIA, it meant money, market share, and a clear identity. The obvious path was simple: make better gaming cards forever. Sell to gamers, sell to PC builders, sell to visual effects studios, keep winning the graphics war. But Jensen Huang saw something stranger inside the chip. The same parallel math used to draw explosions could also calculate physics, molecules, fluids, climate models, and eventually neural networks. This is where NVIDIA made the decision that changed everything. In 2006, NVIDIA introduced CUDA, short for Compute Unified Device Architecture. CUDA let developers use NVIDIA GPUs for general-purpose computing, not just graphics. NVIDIA's own documentation says CUDA allowed computational workloads to use GPU throughput independent of graphics APIs. In simple terms, NVIDIA taught its gaming chips to become science machines. This was not instantly profitable. It was like building a highway before most people owned cars. Wall Street could look at it and say, where is the revenue? Jensen could look at it and say, where is the future? At first, CUDA looked almost ridiculous. Researchers loved it, but researchers are not usually the people who make a company explode overnight. Scientists use GPUs for simulations. Engineers used them for models. Universities played with them. A few labs saw the potential. But for years, CUDA was not the main money machine. The gaming business still paid the bills. That is what made the bet so powerful. NVIDIA kept feeding a software ecosystem before the giant market arrived. It was not just selling chips. It was training the world to write code for NVIDIA chips. And once software habits form, they are very hard to break. Then came Yuntandu, the year the AI world woke up. At the ImageNet competition, a University of Toronto system called AlexNet used deep learning to classify images far better than the competition. The AlexNet model achieved a top 5 error rate of 15.3%, more than 10 percentage points better than the runner-up. The important part was not just the score. The important part was how it happened. AlexNet used neural networks, huge data, and GPUs to train much faster than traditional methods. Suddenly the chip designed for video games looked like the engine of machine intelligence. Imagine researchers had been trying to teach computers to recognize cats by writing rules. Ears look like this, whiskers look like that, eyes look like this. AlexNet said, stop writing every rule. Give the computer millions of examples and let it learn patterns by itself. But that needed insane amounts of math. Not one big calculation, but millions and billions of smaller calculations repeated again and again. That was exactly what GPUs were built to do. NVIDIA had spent years making parallel math fast, cheap, programmable, and available. The AI world did not suddenly choose NVIDIA by accident. NVIDIA had been waiting with the right tool. After AlexNet, the direction of computing changed. Google, Meta, Microsoft, OpenAI, universities, startups, and research labs all began to understand that bigger neural networks needed more compute. More compute meant more GPUs. More GPUs meant more CUDA. More CUDA meant more software written for NVIDIA. And more software written for NVIDIA meant the next buyer had one less reason to choose a competitor. This is the flywheel. Hardware attracts developers. Developers create tools. Tools attract customers. Customers buy more hardware. More hardware gives developers more reasons to stay. By the time AI became mainstream, NVIDIA was not just a chip maker. It was the default road system. The next huge moment was ChatGPT. When OpenAI released ChatGPT in late 2022, ordinary people finally saw what AI could do. Before that, AI felt like a laboratory topic. After that, every CEO suddenly needed an AI plan. Every investor wanted an AI stock. Every cloud company needed more data centers, and every data center needed accelerators. Reuters later wrote that since ChatGPT's launch, NVIDIA's shares climbed dramatically and the company became central to the AI boom. The public saw a chatbot. Wall Street saw a new industrial revolution. NVIDIA saw the world finally arriving at the highway it had built years earlier. This is why NVIDIA's data center business exploded. In fiscal 2025, NVIDIA's total revenue reached $130.0 billion, while data center revenue reached $115.2 billion, up 142% from the prior year. In Q4 fiscal 2025 alone, data center revenue hit $35.6 billion, up 93% from a year earlier. That means NVIDIA was no longer mainly a gaming company. It had become the company behind AI factories. A gaming GPU is something one person buys for a PC. A data center GPU is something tech giants buy by the thousands, then stack into giant buildings that consume oceans of electricity and produce artificial intelligence. The product that made NVIDIA feel almost untouchable was not just a chip. It was the full stack. There was the GPU, like H100 or Blackwell. There was CUDA, the software layer developers already knew. There were networking parts from Mellanox, which NVIDIA bought to move data faster between chips. There were libraries, systems, servers, and partnerships with every major cloud company. Competitors could copy one piece, but copying the whole machine was harder. It is like trying to beat McDonald's by making a better burger, then realizing McDonald's is not just the burger. It is the supply chain, the real estate, the training, the brand, and the drive-through window. That is why customers kept coming back. Training a large AI model is not like buying one laptop. It is more like building a power plant, a factory, and a software laboratory at the same time. If one part breaks, the whole project slows down. Big companies do not only ask, which chip is fastest, they ask, which system has the fewest surprises. NVIDIA's answer was simple. Our chips are fast, our software is mature, our developers are everywhere, and your engineers already know how to use us. In AI infrastructure, comfort is not boring. Comfort is billions of dollars. Then the US government changed the story. In 2022 and 2023, Washington tightened export controls on advanced AI chips going to China, and NVIDIA disclosed that restrictions affected chips such as A100, H100, A800, H800, L4, L40, L40S, and RTX 호동 과yo under certain thresholds and destinations. NVIDIA's own SEC filing said China represented 90% of data center revenue in fiscal 2023, 40% in fiscal 2024, and only a mid-single-digit percentage in the fourth quarter of fiscal 2024 because of licensing requirements. Suddenly, NVIDIA was not just a company. It was a strategic asset in a technology war. Explain that like you are 5. Imagine NVIDIA makes the best toy blocks in the world and every country wants to build the smartest robot with them. Then the teacher says, you can sell blocks to some classmates but not to that table, because they might build something too powerful. NVIDIA still wants to sell. China still wants to buy. The US government wants to slow China's AI progress. So NVIDIA tries to design chips that follow the rules. China tries to find alternatives. And every new rule changes the game again. This is not normal business anymore. This is chips becoming geopolitics. The blocked ARM deal showed another limit. In 2020, NVIDIA announced a plan to buy ARM from SoftBank for about $40 billion, hoping to control one of the most important chip architectures in the world. But regulators and rivals pushed back hard. The Federal Trade Commission sued to block the deal, arguing it could harm competition. The United Kingdom also raised national security and competition concerns. In 2022, NVIDIA and SoftBank abandoned the acquisition. The message was clear. NVIDIA could dominate GPUs, but the world would not casually allow it to own too much of the chip universe. But even when regulators blocked NVIDIA in one direction, demand exploded in another. Microsoft, Amazon, Google, Meta, Oracle, OpenAI, Anthropic and xAI all needed more compute. Reuters reported in 2026 that major hyperscalers were on a path where AI capital expenditures were rising so fast that spending pressure became a major investor concern. That is the strange power of NVIDIA. Its customers are some of the richest companies on earth, yet even they started worrying about how expensive the AI race had become. When your customers are trillion-dollar companies and they still complain about the bill, you are not selling normal products. You are selling the scarce ingredient. By October 2025, NVIDIA's market value reached historic levels. Reuters reported that NVIDIA became the first company to reach a $5 trillion market value, powered by the AI boom, with its stock climbing sharply since the launch of ChatGPT. Reuters also reported that Jensen Huang had announced about $500 billion in AI chip orders and plans involving US Department of Energy supercomputers. That milestone was stunning because NVIDIA had once been a graphics chip company fighting for survival. Now it was worth more than many national economies and had become the scoreboard for global AI demand. The simple reason NVIDIA won is timing plus patience. It made gaming chips before AI needed them. It built CUDA before most companies knew they would need it. It supported researchers before researchers became the center of the economy. It built systems before customers asked for full AI factories. Then, when AI models got huge, everyone discovered that NVIDIA was already standing at the checkout counter. Other companies had chips. Other companies had smart engineers. Other companies had money. But NVIDIA had the ecosystem. And in technology, an ecosystem is a trap that customers often enter voluntarily because it saves them time. This does not mean NVIDIA is invincible. AMD, Google, Amazon, Microsoft, Intel, custom AI chips, Chinese alternatives, and future architectures are all trying to reduce dependence on NVIDIA. Reuters reported that AMD has pushed major AI server deals with companies like Anthropic, showing that competitors are fighting for a market long dominated by NVIDIA. At the same time, cloud companies do not love being dependent on one supplier. If one company controls the most important AI hardware, everyone else becomes nervous. So the next phase of the AI war is not whether NVIDIA is powerful. It is whether customers can escape needing NVIDIA so badly. The software moat is the hardest part to attack. A rival can say, our chip is cheaper. Another can say, our chip uses less power. Another can say, our chip is better for inference. But then a customer asks, will my tools work? Will my engineers know it? Will my models run smoothly? Will the libraries be stable? Will supports exist at scale? That is CUDA's magic. NVIDIA is not only selling metal, it is selling years of developer habit. The longer an industry builds on your platform, the more your platform becomes invisible. People stop saying we chose NVIDIA, they just say this is how AI is done. To understand NVIDIA's power, follow the money inside an AI model. First, a company needs data, then it needs engineers, then it needs a model architecture. But none of that matters without compute. Compute means GPUs, servers, networking, memory, cooling, electricity, and data centers. NVIDIA touches the most valuable layer of that stack. The accelerator layer that turns money into model intelligence. If the model is the brain, NVIDIA sells the neurons and the nervous system. If the data center is the factory, NVIDIA sells the machines inside the factory. That is why every new AI race becomes, indirectly, a race to buy NVIDIA hardware. There is also a darker side to this boom. AI data centers need enormous energy, and companies are building faster than power grids can comfortably absorb. The Verge reported that researchers and companies are increasingly debating the environmental impact of AI infrastructure, while Microsoft has described Fairwater-style AI data centers scaling to hundreds of thousands of NVIDIA Blackwell GPUs. Bigger models need more chips. More chips need more electricity needs more land, cooling, transmission lines, and political permission. So NVIDIA's success is not just a stock market story. It is becoming an infrastructure story, an energy story, and a national planning story. This is the part people miss when they ask, why didn't another company just do the same thing? Because doing the same thing would have required starting years earlier, making strange bets before the reward was obvious, surviving when those bets looked stupid, and building both hardware and software at global scale. CUDA in 2006 looked premature. AI in 2012 still looked academic to many outsiders. ChatGPT in 2022 made the world panic by compute. NVIDIA's takeover was not one lucky moment. It was a chain of decisions that only looks obvious backward. So if a 5-year-old asked, how did NVIDIA take over AI? The answer is this. NVIDIA first made chips for video games. Those chips were very good at doing many tiny math problems at the same time. AI needs many tiny math problems at the same time. NVIDIA also made special software, so people could easily use those chips for science and AI. Then researchers proved deep learning worked. Then ChatGPT made everyone want AI. Then every big company needed NVIDIA chips faster than NVIDIA could make them. That is it. Video game math became AI math, and NVIDIA owned the bridge. And that is why NVIDIA's story feels almost impossible. It started with a Denny's conversation, nearly died on the wrong chip, survived through gaming, quietly built CUDA, waded through years of doubt, caught the deep learning wave, rode the ChatGPT explosion, and became the company every AI builder had to call. It did not take over the AI world by owning the apps. It took over by owning the machines underneath the apps. The world wanted artificial intelligence. NVIDIA sold the picks, shovels, roads, engines, and power tools. And in the biggest technology gold rush of our lifetime, that was the best business on earth.